Hello students, in the last class we learned about the three basic structural forms of axial flow compressor rotors. In this class we will learn about the connection between the axial flow compressor rotor blades and the impeller drum. First, let's take a look at the working blades of the compressor. The working blades of the compressor are one of the important parts of the axial flow compressor and are mainly composed of two parts, the blade body and the tenon. In order to meet the requirements of aerodynamics and strength, the blades of the compressor blades are generally designed with blade profiles that are suitable for subsonic or supersonic operation, and the blades are designed with regular twisting. In order to reduce the weight of the engine as much as possible, the chord length of the blade tip is usually narrower than that of the root, and the thickness is thinner than that of the root. On some blades, a boss is often installed in the middle of the blade. Students can think about what the function of the blade boss is. The boss is generally located at about 50% to 70% of the blade height from the blade root. The role of the boss is to change the natural frequency of the blade to avoid dangerous resonance or flutter. Secondly, the boss can also increase the rigidity of the blade and reduce the bending and torsional stress at the root of the blade. The existence of the boss will inevitably bring some disadvantages, such as increasing the weight of the blade, which increases the centrifugal load of the blade. The connection between the blade body and the vibration damping boss is locally thickened, which reduces the flow area by 2%, reduces the intake mass flow rate, and affects the thrust of the engine. In addition, the vibration damping boss will also cause airflow pressure loss, reducing the efficiency of the compressor. Therefore, in modern advanced aircraft engines, wide chord fan blades are used to replace narrow chord fan blades with vibration damping bosses. Compared with narrow chord fan blades with vibration damping bosses, wide chord fan blades have the advantages of large cascade channel, area wide, surge margin, high stage efficiency, and good vibration reduction. Next, let's look at the connection between the working blades and the impeller drum. The working blades of the compressor are generally connected to the tenon on the impeller through the tenon. Therefore, the design of the tenon mainly has the following requirements. First, the load on the blade body must be reliably transferred to the impeller under the conditions of small size and light weight. Second, the working blade must be accurately positioned and reliably fixed. Third, it should have sufficient strength, appropriate rigidity, and reasonable stress state to avoid stress concentration as much as possible. Fourth, the structure should be simple and easy to assemble and disassemble. Based on the above requirements, the tenons of compressor rotor blades usually have three types: dovetail, pin, and fur. As shown in the figure, the first picture is a dovetail tenon, the middle one is a pin tenon, and the last picture is a fur. Dovetail tenons can be divided into two types, longitudinal and circumferential, depending on the direction of the tenon groove. Dovetail tenons have the advantages of small tenon size, light weight, and the ability to withstand large loads. Therefore, they are widely used in compressors. Its main disadvantage is that the force-bearing area at the bottom of the groove is small, and it cannot withstand excessive loads or install more blades. The dovetail tenon is inserted into the dovetail tenon groove of the wheel disc, and generally relies on the side of the groove for positioning and force transmission. The tenon and the tenon groove can be matched with a transition fit or a small clearance fit. The use of clearance fit makes it easy to install the blade and avoids installation stress in the tenon groove. The pin-type tenon generally places the working blade on the rim by means of a lug or inserts it into the ring groove of the rim and relies on the pin or bushing to bear shear and transfer the blade load. There is a gap between the bushing and the lug hole, and between the lug and the side of the wheel disc, which allows the blade to swing around the pin during operation, which has the effect of shock absorption and eliminating additional stress at the connection. The advantage of this tenon is that the assembly process is simple and does not require special equipment for processing, but the load-bearing capacity is limited and the size and weight are large. Finally, let's take a look at the fir tree tenon. The fir tree tenon is generally wedge-shaped and the tenon groove is inverted wedge-shaped. Compared with other forms of tenons, the fir tree tenon has the advantages of small circumferential size, light weight, and the ability to withstand large loads. However, it relies on multiple pairs of tenon teeth to transmit force, which leads to severe stress, concentration, and poor processability. Therefore, this type of tenon is rarely used in compressors, only in the first few stages with heavy loads, or the last few stages of high-pressure compressors with high temperatures. Students, in this class, we have learned about the composition and characteristics of compressor blades and the 3 ways of connecting them to the impeller drum. Students must memorize these 3 ways of connection and match the names of these 3 ways of connection with the real objects one by one. Thank you everyone.